Okay, so now we're recording our Claude demo for Pub Health AI. And in this demo, as I mentioned, we're going to also create a synthetic data set using the California Department of Health's influenza vaccine recipient data dictionary. So this is the interface for the free plan of Claude here, and it's looks familiar to folks who've interacted with LLMs, in a web interface before. So I've got the chat. This is it. Claude's a kind of a helpful robot. It's kind of a helpful persona. Uh, and you can also do these things called projects, basically where it brings together the chats and the file uploads and things that you've used to, like, it just consolidates stuff around certain topics that you want to look at. So um, in the free tier, you only get one of these projects, and it's not necessarily guaranteed to remain over time. They just put a disclaimer on here that they'll purge it. That hasn't happened yet to me, but one at a time is the way it goes. And Claude's creations, it calls artifacts. So this is where you find your own artifacts, things you've been working on, things that other people have built, which may or may not be relevant to what you're doing, but it's kind of fun to poke around sometimes. So I'm going to run all of this in the context of a project, which is, um, just to keep things together. But you could easily run this through chat prompts as well. And the another limitation to the free tier of Claude, so the paid tiers, the pro is $20 a month, I think. But for free tier, you can only do text documents. You can't upload Excels or CSV files or anything that's not in a text format, just, you know, for anybody who wants to know. So first, what we're going to do is open up this the CDPH website here. I don't know if Tomas Leon is on, but props, CDPH always doing good work. And we are going to go get the Word doc over here for the Snowflake. They use Snowflake for their data warehouses in California. And what we're looking at here is, come on, let me move it. Okay. So this is their data dictionary for their publicly available influenza recipient data, for, this is the all the fields. I think there's about 45 of them on, on who's getting what kind of vaccine when in California, right? So this is awesome, gives us, data elements, variable names, descriptions, value sets, codes to look up. So the interesting reason that I wanted to pull a synthetic data demo into just showing how Claude works is because so many times, and I'm sure many of you have experienced this as well, you get sort of stuck in the loop of data sharing agreements and confidential data and not really being able to move things forward in an accelerated way when there's an analysis that needs to be done, right? And being able to synthesize data based off your own data dictionaries would make it easier to, say, share those data outward with researchers who are prototyping models, or to be able to share even across divisions in your own agency, or with you know academic partners, to be able to get started right away while you're waiting on this confidential data sharing agreements to happen, or to you can prototype code and then run it later. It makes sharing a lot easier, and it also would give you a chance to, say, test a model on synthetic data just to see how it performs versus real world. There's a lot of applications. And is everybody able to see the CDPH registry data? Okay, Allie does. So, all right, so that's just an example of what we're going to use in Claude, right? So I'm gonna click out of this, and where's this one too? Sorry, I'm still traveling, so I'm on a spare monitor here. So what we're going to do first is open up the data dictionary that we just downloaded. So this is something we can do in free tier Claude because this is a document file, right? And then we're going to give Claude a prompt, and I'll send this prompt around later as well with the demo. So I'm going to ask Claude to create an interactive synthetic data generator that produces realistic synthetic records, right? We don't want just a one-shot thing. We want to have this so we can iterate over it. We can change the number, how many records we want. It's just a matter of running another query. So we want to say generate a new data set on demand, have a CSV file that we could download, take it to another program, or use it for further visualization. And so I want to be able to scroll through the records so I can see what's in there. And I want the data to be realistic and follow the format of the data dictionary. And I want to remind Claude that I want this done as an HTML artifact so I can interact with it, and embedded in JavaScript so it's functional. One of Claude's gaps, let's say, that I found in putting this demo together is that it will create a nice HTML looking dashboard, but it doesn't run, right? And that's fine if you want to pull the code out on the back end and go put it somewhere else, tweak it, attach it to whatever data sources you need. Gives you something to start with, but I want to make sure that this is gonna run so I can at least, poke around with it. And I want the interface to look nice. I mean, nice is a matter of opinion. So let's see what the LLM comes up with here. So that is the first prompt. So, as always, let's do it live and see what happens. So as you can see over here, it's running through its HTML code to create the layout of the website, right? I didn't give Claude any sort of specifications around representativeness for these data. And that's actually something that's a little bit tricky because so this is just meant to mostly be an example, but if you were actually wanting representativeness of your immunization registry data, you would need to know the proportions of the people who've actually been reported with vaccines in California. So that's not something that I had access to right away. The immunization registry, everyone in there is going to be vaccinated. So if you want to do representativeness, you can absolutely do that. And we'll get into that in a little bit. But most of the data that's available is percentage of the population that's been vaccinated by demographics and socioeconomic stratification. So it ends up being not as it's not an apples to apples comparison, let's say. So this is what we have here. This is our output. And this is, yeah, it looks pretty. We have 100 records. It's got its recipient ID, date of birth, and I went through and checked these values against the data dictionary in a prior run. It looked pretty good. You can scroll through, can scroll up and down, take a look at what's there. You can see the code if you want to toggle over here from the kind of visualization view to the back end code view. You can copy that all out if you want to take it out as an HTML, if you want to put that code into your project. That's another nice thing about the the project setup is that you can basically just create that archive of everything, so you don't have to go back to the chat and pull the code, and it's there. And you could edit it elsewhere if you wanted to, say like what does this do? Explain this to me. So it can just gives you information on what you're clicking on, and that's it's just some random browser tag, but so you can get a little bit of contextualization of what it's doing here in the code as well. But if we go back to the dashboard, you can see, let's say we want to generate another data set, so we can see there's some missing data in there. It's added like unknowns. It's added, these are all, you can basically see the contextualization here change at the top of the summary. And if we want to download it in a CSV, there you go, download file, and you can go and take a look at it. So let me pull this over onto the screen here. Yeah, so you can just you can see what you've got. And these are all fine. They're just truncated right now. So you could easily take this and use it as data that's been practice data, build a dashboard off of it, see how it does, plug it into the real data. It makes it easier to prototype. And if you say needed 50,000 records of something, this is a pretty quick way to get them too. I mean, the 100 record generation took, I didn't even notice how long it took because it was so fast, right? So that's a quick way to do it. And then we can go into, well, first let me stop and see if anyone has any questions about how we got here, or what else we can do with just this piece of it.
Wondering why you chose the data dictionary instead of like a message mapping guide.
Ease of reading quickly, makes it something that's quickly human readable. But if you have a message mapping guide, we could try to do the same thing and take a look at that kind of synthesizing those types of data elements as well. If you have one that you use that's open, just drop it in the chat and we can load it up. Any other questions? All right, so let's keep going with this then. Sujata, I see a question from you. Could you unmute and ask, please?
Oh, sure. Sorry. I guess I was curious if there's a way to account for variables that tend to be correlated with each other. So like with like name and gender, for example, or in the example you have here, like I'm curious if like age and type of vaccine administered might have an association. So is there a way to train Claude on picking up those patterns?
Yeah, I think that's a great question, and that's one way that you can encourage sort of data realism, right? Even in your synthetic data. So there are ways that you can with the prompt sort of so you could either feed it rates or things that are correlated into that project when you're creating the prompt, and we'll do that in a minute. Where if you want it to say like make the distribution of your population look like this, you can sort of feed those things into in aggregate into the synthetic data set creation process, and then check the output to make sure that it's it's not going to be perfect probably, but it'll be pretty close. And you could also just put in an element in there to say, like if the how to like statistically describe the correlation that you're looking at, you could just tell it how to do it. And then this is definitely a trust but verify sort of activity. Like with all things AI, you have to just know what you were looking for and what kind of result you're looking to make sure that you're getting the thing. But you can um, bake that into the prompt, right? Like I just put in some pretty basic requests, but you could do that. You could actually point it to, say, federal data or state data that are open data on certain things and have it include those in its creation process. But you'll have to double check the output to see if the trends hold that you're looking for. Go ahead, Tyler.
Yeah, and sorry if this is jumping ahead. I'm just curious, like how to prompt it to create some more data quality issues that we might expect, and I guess maybe that's closer to the representativeness. But I'm just thinking through like maybe a data dictionary is how everything should be, and we know that's not always the case. So what else? What other documents we could provide it that would maybe help?
Yeah, that's baking in the mess, right?
Yeah.
Yeah, dirtifying your own synthetic data. But the data dictionary gives you the structure and the format of what you want, but synthesizing data based on errors that are kind of known issues, or if you want to ensure sparseness in your data because you're going to have to do some imputation or whatever, like that's all stuff you could ask for. I have not done that yet, but I think it's a really good experiment and I'd like to try it. So I mean, we can just see how it goes too here in a few minutes. So think of like something that you'd want to see as a mistake, and we'll see if we can get it to generate that credibly. Ryan, go ahead.
And yeah, I just wanted to share, earlier this year, we needed synthetic populations and we came across some work that PJ Harvey had done. This wasn't AI related, it was more data science related. He simulated state populations for a couple of different states and even introduced some random errors. So I'll just drop that in here, but it was great for us to test our stuff out.
Yeah, that's very cool. I am really interested to see like how much further we can take this. This is something I'm just now kind of getting into, but I think there's a lot of options for this. I think, especially as I see Jamie Ritchie from Arizona was said that this kind of thing could easily be done for training data. So if you're holding a training and you want people to do some sort of analysis or learn to use a tool, but you'd like for them to do it on a data set that's closer to the reality of what they're going to be working with and not a height and weight distribution kind of thing or whatever. This is the kind of thing that I wish I would have had back in like teaching days. Make things a little bit more realistic. So
Not just 10 people named after Simpsons characters.
Yeah, the Mickey Mouse data sets. Oh gosh. Yeah. Or like real world data being way messier than anything students are typically presented with. So let's go on and let's see what we can do about pulling some representativeness into this, but with the caveat that I put out earlier that we are not looking at the full like immunization data for California. This is just a kind of an approximation here. So I just switched over to the pro version, which I recently got here. I hope that's in the frame. Notes too. So the use cases for Pro that I've found so far are that you can have more than one project. You can put more kinds of data into it. You can have, Excel or unstructured data that you want to analyze. So since we can't upload any data to the free tier, I'm just going to switch over to the paid tier, and then we're going to do so I've got a couple dashboard iterations here, but we're going to run through it again. So the idea here is that I want to create a dashboard to make this. Actually, you know what? I think I'm gonna try to do the representativeness thing first, and then we'll get into the the data viz outputs. So let's take a shot at doing an interactive basically doing that same data set generation, but then pegging it to the data elements that we have from so I just pulled something off the Kaiser Family Foundation website yesterday with the state data for California, their immunization rate. So this is oh, there's Callie. Oh, did it not? Okay, so this is just really basic stuff, looking at their overall vaccination rate. So again, the immunization data is really everybody. This is just, half the population roughly with vaccination. But it gives us a sense of whether or not Claude can approximate something that we feed it, right? So we're gonna go back to our data dictionary. So we're gonna run it all again. There's our Snowflake data dictionary. And we're also gonna pull in the raw data from California that I pulled down yesterday. It's just some race ethnicity rates, really simple tables, not anything line level. And then we're going to go back to the same prompt that we put in before. And so so this is something different here. Like I asked it to sort of use California data from 2023 to 2024 to get some sort of representativeness. Again, you would really want to be more specific in how you're specifying that if you have something particular that you want it to do. And then I'll just remind it to make it actually work and make it look pretty. So let's see how we do here. So this should give us a generator with the California rates reflected. So it's going a little bit through the data. So it analyzed the file that I fed it a minute ago, extracting the variables from the file and using those to create the data set. And now it's running the HTML code to actually package that output in the way I requested. Sometimes it takes a little while, and occasionally you'll find during your sessions that if the conversation length gets too long, you'll have to just hit continue. So it pays to pay attention to what it's doing when it's running. So just while we're looking around here, how many of you have actually used Claude? Just throw the hands up there. Okay. All right. I see some thumbs. All right. Wow, this is so pink. It's always fun to see what happens when I tell it to. It was not going quite this this but this is giving me very summer vibes here. I think Claude's Claude's at the beach or something,
Also, it looks like you picked like Marin or Santa Monica, given those vaccination rates.
right? Right. So let's take a look at what it's actually doing here behind the scenes before we get into it. So it's giving us the same synthetic generator we did before with the same kind of 100 record data set, using, so it's pulling actual California vaccination rates. This is what we had in the file that we sent it, and age-specific vax rates, and putting those into the data set. It is telling us what it's trying to do here. And I haven't gotten into this sufficiently to really do the testing to see if it's doing what it says it is. But you could probably review the code and double check its approach on the back end. And then it gives us this data set. So we have, same as before, we've got our IDs. It's giving us single digit IDs. It gets a little bit creative sometimes with how it approaches IDs. So if you wanted it to have something, say, in a certain format, you would just code that in as the format that you're looking for. We've got the data in here, provider, counties in California, and we've got names in here, all of these, again, synthetic, date of birth, synthetic, but most of it checks out in terms of, if you're eyeballing, you see that, you've got your records listed. I'm not going to go all the way down here. And if you want to generate another data set, this vaccination rate looks closer to the state average. I think it's probably, I think the flu vaccination rate for kids is higher than that. So if there were certain percentages that you really wanted it to adhere to every single time, you would need to mark those in. But it's also, if you're looking at longer periods or something, that it's going to be more variable. So again, we can download the CSV file to wherever we want to, take a look at it, and here we go. It's definitely truncating the field list a little bit. So I think that I liked the prompting strategy before of putting in the just feeding it the full data dictionary and not trying to add anything in, because it seems like it's maybe a point of confusion for it that it didn't pull in the entire scope of that data dictionary the second time around. And this is something that is kind of I've noticed this with a lot of different models, that the more tasks you stack into one prompt or one session with it, the likelier it is that it's gonna get a little bit funny sometimes in your output, or that it's not going to do quite enough. So if we wanted to have it follow all those variables, we could just ask for it to run again, or really I think just getting the data set that you want, then you get something that you can make sure you get something you can use, get that format that you like, and then you can just iterate from that rather than starting from scratch every time. And let's see. I see a comment from Ian about creating synthetic data from hospitals. You probably shouldn't use the actual names of real hospitals, because the context doesn't always travel with the data set. And I think that's a really good point, Ian. Thank you for that. And that's something that you could code out, like if you're using a data dictionary or some other structured format to create that synthetic data, then as part of your prompting, you could say, like, randomizes or anonymize the names of hospitals, or create synthetic names for the hospitals as well, or in whatever structured data set you're feeding into it, you could have a mapping on the back end for that if you wanted to. But yeah, that's a great point, Ian. Thank you for making that. Ian has been my phone a friend on validating models, how to validate the synthetic data sets here, because Ian's one of our resident modeling experts at Washington Department of Health and has some very helpful commentary on this that I'll share out in the notes as well. So that gives us our, that's how you would take and just add in whatever data you're wanting. But again, you're gonna need to iterate to make sure you get the format that you're after with the end result. And so what we can do now, and this is more just like a widget for how Claude works, and it gives you kind of code that you can iterate for, or iterate from for a dashboard. So let's look at how we would create an interactive dashboard. I started with doing this in the free tier, and it just didn't work because I couldn't upload the Excel file to actually do it. And this is how I learned the part about actually telling Claude to use HTML rather than, so you do have to specify quite a bit. So I'm just gonna start another chat in this project here. I already did that. So let's take the file that we downloaded earlier for the synthetic flu data. And then we can pull a prompt together to show the interactivity here that we're looking for. It's kind of going over the same structure of prompt. So we want it to be a dashboard. We want to have this to be actually. So I'm asking Claude to embed the CSV file in hard code this on the back end for me because I want it to run. So that's something that if you're taking if you're taking the code out of Claude to go put it into Python or something somewhere else, you want to make sure that it points to the data, and you don't really want to hard code your record set into your data, right? Because then you're going to be stuck maintaining that, and it's not going to be dynamic, and that's not a good idea for code maintenance purposes, but for the the fact of getting this to run in a demo, that's a choice, but don't do it for real unless you're just trying to work entirely within the confines of your model for something specific. So we want to have just drop down filters, basic visualizations, like the summary cards at the top, typical dashboard stuff, right? We all see these dashboards all the time, and we probably all made quite a few of them. And I want it to use some JSON for visualizations to make sure that it actually works. And then I want to use the attached data here to drive the dashboard, just to make sure that I'm being super explicit with it. It feels a bit heavy-handed sometimes, but you really do have to tell these LLMs exactly what you want them to do if you want to get something to look right repeatedly. Let's see what happens. And on we go. Same sort of process, repeated again. And in the pro tier, just as an aside, you can choose from more models. You've got lots of options here. Opus is the most recent one. That's the bigger one for more complex stuff. Sonnet is what I'm using now, and that's what I've used all throughout this. It's kind of their basic. That's the everyday model. And in the free tier, you can access all those models, but there are utilization caps for for Opus and I think a few of the other ones. So you get broader access to model with no limitations on it. Right. It is really fun to watch code, just isn't it? I mean, I think about how much time saving this could be for folks, especially the people doing visualization work. So the reason this is taking a long time is because it's actually hard coding those values from the data set into the table that we had. But I can come into here. We'll take a look at that later. But this is, let's look at the artifact that we had from. So this is yesterday's run. Again, like super California, pink and blue. Ryan, you cracked me up with that Marin reference. So is this exactly what you would want to publish on your state's open data website? Probably not. But it gives you, again, like the ability to pull the code out of it. And this ends up being dynamic. So we've got our 100 records, our, the kind of, this is a different set than what I'd used before. So let's just say we update the dashboard and it pulls the statistics through, it pulls the, I mean, this would not pass any muster with Alberto Cairo or any of the other Viz gurus out there. But it does give you a very quick summary of what's in your synthetic data, and it's it's realistic for counties in California and whatnot. So there we have that, and it's pulled in just a subset of the records that that I was working with yesterday. That is that for Claude and creating synthetic data. So a few comments that Ian was kind enough to pass along, that so in terms of validation, you want to look at just do the proportions of occurrences in your data actually sort of match what you would expect from your knowledge of real world data, right? That's the easiest way to compare. But then, further, especially if you're doing modeling work, do your conclusions that you draw from analysis of synthetic data match the conclusions, the analysis results you would get from looking at real data? That's the next step in figuring out if you've really got something that you can use there, if you need to do sort of further iterations to get there. And of course that depends on what you're looking for and what kind of use cases you're looking at, but you're not going to have total fidelity between your synthetic data and your actual data, because then you would not have synthetic data anymore, right? So there's always going to be a little bit of a gap. But and you can use synthetic data for model implementation, to just sort of, look at developing models, and generating synthetic data to see if it's like, sufficiently similar to real data for external partners to use, and modifying models they've developed. Like that's been a use case that we've had with Washington, for CDC wastewater, doing wastewater data modeling with CDC, and great for testing and implementing code as well. Like another example that Ian shared was like if you're using EHR data as a source, then implementation of code may involve pulling a lot of data from an EHR, but a EHR may not be able to handle the volume of data pools that would be required for model testing. So having synthetic EHR data would be really useful in that type of scenario. So I think this is meant to just be a very basic quick way to do data synthesis, but it's there are tweaks that you could add, and I think in this case, I would encourage experimentation with prompting, along the lines of Tyler's question earlier, like, how do you add dirt? Do you say, make age track with, something else that's relevant around vaccines? Do you have rates in certain areas be lower? And I think figuring out how to add those in and then looking at your synthetic data and basically running the analyses on it that you would run on your real data will show you whether you've got something that's like what it's viable for downstream use, right? If you have, is this good enough that you can like train a statewide wastewater surveillance model on the synthetic data, or do you need to, or develop, not train, or do you need to, kind of keep working on it basically until you get what you want, or is there another approach outside of using an LLM that's better? But for small uses like, creating a data set for a training that you're hosting, like this, can do it in a few minutes typically, which I think those I like those time saving things. So questions, thoughts, any uses you could see for this? I'm gonna go ahead and stop the recording now, and then we can where's my recording? Okay.